Hi, I'm Dr. Samantha Zaroff, a product manager at GenScript. GenScript is a world-leading contract research organization, and we specialize in custom antibody generation, and we have for the past 15 years. So today I'd like to talk to you about why we personally like to use hybridoma technology when generating our antibodies. So for the past 35 years, there's been a debate between two major types of antibody generation technologies. The first would be based on the B cell isolation. So from there, you would immunize an animal and then isolate the B cells and antibodies subsequently from them. The other is phage display technology, which is more based on recombination of variable heavy and light chains into a bacteriophage and then looking for antigen-antibody binding from there. So with all of these different types of technologies out there, how did we decide to move forward with hybridoma? So first, I would like to give you some information on exactly what hybridoma technology is. So in order to make a hybridoma, first a mouse or a rabbit, whatever model species you're working with, will have to be immunized with your antigen of choice, usually a protein or peptide. From there, you'll go through multiple boosts of this antigen in order to elicit an immune response in the animal. Then you're going to have to isolate the spleen and the B cells directly from the spleen in order to find antibodies, because B cells are the cells of the immune system that produce antibodies. After that, you will fuse the B cell to a cancer cell, usually a myeloma cell, in order to have a hybridoma, which is a fully immortalized B cell which is able to constitutively express antibodies for as long as it remains alive. On the other hand, you have phage display, which, like I said, you take the B cell and then you will PCR out the variable heavy and light chains and then do recombination and multiple transfections of an E. coli-based system in order to have bacteriophages with multiple different antibody sequences on the outside. So with these two, like I said, GenScript would rather work on the hybridoma technology. So there are multiple benefits to hybridoma technology. So the first, like I said, it's been around since about the early 70s. So because of this, it's gone through a lot of maturation and optimization in this technology. And because of this, the FDA actually would rather work with hybridoma technology generated antibodies for therapeutics and diagnostics. Secondly, hybridoma technology is the most cost-effective and time-effective technology in order to generate antibodies. Specifically, hybridoma technology usually ranges from about $4,000 to $8,000 and takes about 4 to 6 months to generate between 2 to 5 milligrams of purified antibody. On the other hand, phage display can take anywhere from 2 months to 8 months, depending if you're doing a naive or an immunized library, and then it can cost upwards of $20,000. And then if you want to go to the next level, to single B cell sorting, that can cost even more, and it will take more time because you're going to get a highly specific antibody. The third is that hybridomas work off of the natural immune system. So when the mouse or the rabbit is injected with an antigen, you'll actually go through the animal's immune system and create B cells specifically made for that antigen. Therefore, the antibodies are highly specific and have high affinity. So you won't have to go through affinity maturation like you usually have to do with phage display. Because of this, they're great for development of antibody therapeutics, and they're also great for assay development. Lastly, phage display relies highly on the transcriptional and translational machinery of the E. coli system. So because of this, you're actually translating not only the variable heavy and light chains in a recombination sort of manner, but you're also translating the bacteriophage. So because of this, there's a lot of error in the sequences for both the bacteriophage itself, the presentation of the single chain variable fragments, or the Fabs, on the outside of it, and then the antigenic binders, which would be on the outside where the antigen's going to bind to. So because of this, we like to use hybridoma technology at GenScript, and if you want to learn more, you can check out our website, www.genscript.com. Hope to see you there.